Hey everybody, today we're going to take a look at proportional relationships and how you can identify a proportional relationship in a table, a graph, an equation, or an example or a word problem. What I'd like you to do today is actually open your toolkit to page 31 because we're going to start by reading this over together and adding some notes as needed. So, a relationship is proportional if one quantity is a multiple of the other. This relationship can be found in tables, graphs, and equations. If we look at a table, we'll see that the equivalent ratios of y divided by x can be seen in the table. So let's take a look at what that would look like in a table. Take a minute to copy down this table in your toolkit, and we'll use this as our first example. In order to tell if a proportional relationship exists, we can test a couple different things here. Okay, according to your toolkit, if we take our y and divide it by our x, we'll get the same ratio for all of these. So in this case, right here I would do 6 divided by 2, and I get 3. Here, I'm going to slide this over here for you. We'll do 6 divided by 2 and get 3. Here I'm doing 15 divided by 5, I get 3. 24 divided by 8, I get 3. 30 divided equals 3. And 90 divided by 30 gives me 3 as well. So according to our toolkit again, when you take your y and divide by your x, if the value is equal for all of these, if those ratios are equal, then we know that a proportional relationship exists. So since our y divided by x for all values in our table equals 3, we know that this is in fact a proportional relationship between our x and our y. Okay, so that's one way to test, is divide y by x. Okay, another way that you can see that though, guys, is you can look across your table as well. Let's look from, say, 2 to 8. I ask myself, how do I get from 2 to 8? If I multiply it by 4, I get 8. Well, take a look at your y value. If we multiply our y by 4, we should also have a number that's 4 times bigger. In this case, 6 times 4 is 24. We quadrupled our numerator, quadrupled our denominator, and we know then that this is a proportional relationship. Okay, see what happens if I use, let's look at a different color here to kind of make it stand out. If we do 2 times 5 to get 10, 6 times 5 would give me 30. And that'll work all along the way here. I can do this now with 5 and do 5 times 2 is 10. 15 times 2 is 30. I know it's getting a little messy here, but just try to show you the point. Again, the last one, 10 times 3 is 30. 30 times 3 is 90. Let's look at this one and see why this is not a proportional relationship. Okay, I'm going to do the test with the y divided by x to see. So for this one, I have 8 divided by 2, and I get 4. 12 divided by 4, and I get 3, and right there I know already this is not a proportional relationship. As soon as one of those values in the table comes up with a different ratio when you divide your y by your x, you'll know that that's not proportional. So no proportional relationship exists in this table between your y and your x. So now we can see that you can tell if a proportional relationship exists in the table because when you take your y and divide it by your x, that ratio will be equal across your whole table. Okay, now let's take a look at what happens on a graph and how you can tell by looking at a graph. Graphs are actually pretty easy to tell. If it's a straight line that goes through the origin, then there's a proportional relationship. And it'll always be a line that increases up to the right, like this one down here. This is an example of a proportional relationship. It starts at 0, 0, and it goes up to the right. It's a straight line. That's a proportional relationship between, in this case, the pounds and the cost. All right, and then a final one we'll look at is in an equation and how you can tell if that relationship exists. Okay, any equation that's written in this form, y equals k times x, is going to be an equation for a proportional relationship. So some examples would be like y equals 3x, maybe y equals 7x, y equals $1.50 times x. Any of those where you're multiplying x by something to get y will represent a proportional relationship. And we'll do a lot more of these in class, but that's just kind of the introduction for how to tell in a table, a graph, and an equation whether that proportional relationship does in fact exist. So down here we've got two examples. Example 1 is an example where there is a proportional relationship. Okay, and I'll let you guys read that over on your own here. But I want to point out that example 2 is not proportional. And it would be good to just note that right now in your toolkit because you can see right away on your graph this is not proportional because it does not go through the origin. I can see on my table it's not proportional because if I take 6 divided by 1, I get 6. If I do 7 divided by 2, I get 3.5. I don't have a constant there when I divide my y by x, so that's another reason that that one is not a proportional relationship. And finally, you can see why it's not by looking at this equation. It's y equals 1x plus 5. That plus 5 at the end is enough to make us know that it's not proportional, since it has to just be y equals some number times x, nothing added on at the end. Sometimes you'll see problems like this where you'll be given a table and you'll be asked if this represents a proportional relationship. So to find out here, let's divide our y by our x. And in a table, the number or the variable that comes first will be our x, and the second one will be our y. Okay, so let's do 3.56 divided by 4, and we get 89 cents, so 0.89. 6.23 divided by 7, and I get 0.89. And here I do 8.9 divided by 10, and I get 0.89. So in all three cases, when we divide our y by our x, we get 0.89. So it is a proportional relationship. And in this particular problem, it means that it's actually 89 cents per apple. All right. Oh, and we could write an equation from this. Y equals 0.89x. And you know if we did a graph, which we're not going to do, but our graph would start at 0, 0, because 0 apples would cost $0. And it would go up in a straight line to the right, meaning it would be a proportional relationship in our graph as well. Here's a final example. It costs $5 to get into the fair and $2 for each ride. Is this a proportional relationship? Okay, to set this up, I would start with a table here and say, let's go the cost and how many rides they go on. Okay, now if you go on 0 rides, you still have to pay $5 to get into the fair. Okay, if you go on 1 ride, it's $5 to get in plus the $2, so 7. If you went on 2 rides, it would be the $5 to get in plus 2 and 2, $2 for each ride, so $9. 3 rides would cost you $11, and it would keep going up from there. All right, so let's look at our table and see if this is in fact proportional. And if you start by dividing your y, your cost, by your x, the rides, you'll see that this is not a proportional relationship. Okay, 7 divided by 1 is 7, but 9 divided by 2 is 4.5. And 11 divided by 3 is 3.6. Repeating, in this case, it's not a proportional relationship. And that makes sense because we had to pay this $5 to get into the park. So if we double the number of rides we went on, it's not going to cost us twice as much because of this entry fee we had to pay at the beginning. And you'll eventually learn how to write equations for this, but it would look something like this. Y equals $5 to get in plus $2 per ride. And you can see that this is not in the form that an equation would have to be in for it to be proportional, because we have this extra 5 on here. All right, it's not just y equals 2x, it's 2x plus 5, which means it won't represent a proportional relationship. All right, that's it for tonight. If you guys have questions on this, please talk with me. As always, I'm here to help. This can be confusing, so make sure you ask when you get stuck, and I'll see you soon. Thanks, bye.